Hi everyone, today we're going to go over some practice problems for dynamics. Starting out, a 5 kilogram block is pushed across a frictionless surface with a force of 20 newtons. What is the acceleration of the block? For this we can use Newton's second law to solve for the answer. Newton's second law states that the force is equal to the mass times the acceleration. If we rearrange to solve for acceleration, we get that the force divided by the mass is equal to the acceleration. Now, we know that the mass is 5 kilograms. And the force is equal to 20 newtons. So if we plug these values in, we get 20 divided by 5, and these are both in their standard units, which will give us acceleration is equal to 4 meters a second squared, because it's in the standard units. Next up, a 10 kilogram box is sliding across a horizontal surface with a coefficient of kinetic friction of 0.3. What is the frictional force acting on the box? Let's write down the variables that we know. The mass is equal to 10 kilograms. And the coefficient of kinetic friction is equal to 0.3. To solve this, we'll use the formula for the frictional force. In this case, the normal force is just going to be equal to the force of gravity. Plugging in the values, we find that the normal force is equal to 10 kilograms multiplied by 9.81. This is equal to 98.1 newtons. Now, to solve the frictional force, let's plug in the values that we have now. This is equal to 0.3, or the coefficient of kinetic friction, times the normal force, which is 98.1 newtons. And this gives us our answer of 29.4 newtons as the frictional force. For this next example, two masses of 3 kg and 2 kg are connected by a light rope and are hanging over a frictionless pulley. Find the acceleration of the system. Let's let the first mass, called M1, be the 3 kg mass. Then the second mass will be M2, which is the 2 kg mass. We can draw out this example to help us visualize it. It should be obvious that since this is a frictionless system, it will fall in the 3 kg direction because it's heavier than the 2 kilograms. But let us calculate this acceleration. We need to find the net force acting on the system, which in this case will be the force of gravity from mass 1 minus the force of gravity from mass 2. can rearrange this by factoring out the g, so we just have that the net force is equal to the first mass minus the second, all times it by gravity. Now let's solve for the net force by plugging in the variables. So it is equal to 3 kilograms minus 2 kilograms times it by 9.81 meters a second squared. And this is just equal to 9.81 newtons. I should note that because everything was in the SI units, so we have kilograms, the gravity was in meters a second squared, that the force will be given in SI units as well, which is newtons. Now, let's solve for the acceleration of the system. To do this, we can use Newton's second law, which states that the force is equal to the mass times acceleration. However, we need to solve for the total mass of the system. So this is just equal to the first mass plus the second. Which is equal to 5 kilograms. Now rearranging the F equals ma to solve for acceleration, we see that we need to take the force and divide it by the mass. That'll give us acceleration. So plugging in the values that we have 9.81 newtons divided by 5 kilograms, which gives the acceleration of 1.96 meters a second squared. And once again, the acceleration is given in SI units because the values that we used in the equation were all SI units. For this last example, a 5 kilogram block is placed on a 30-degree inclined plane. The coefficient of static friction is 0.4 and the coefficient of kinetic friction is 0.3. Determine if the block will slide and find the acceleration of the block. So we can draw this problem out to help us visualize it. Now I'll draw a free body diagram to this side so that we can see the forces a bit easier. You could draw it on this diagram, but it can get a bit messy, so I'll just draw it here instead. So there's the normal force as perpendicular to the plane it's sitting on. The force of gravity will be trying to pull it down. And the friction force will be acting opposite to the force of gravity in this case. So how are we able to actually find these forces? We know that pulling straight down is just force of gravity from the y component, which is just mg. Now if we extend this normal force, or take the parallel component of it, we could draw it this way. Whereas we're left with this angle, it's 30 degrees. So now to find the normal force, if we use SOHCAHTOA, we can see that this is adjacent to the angle, meaning that the normal force is equal to mg cos of 30. Likewise, we can use SOHCAHTOA to find the force of gravity. We know that the force of gravity is acting perpendicular to the normal force, meaning that we'll take the sine instead of cosine. So that leaves us with the force of gravity is mg sine of 30. Now let's calculate these values. So the normal force is equal to 5 kilograms times it by 9.81 cosine of 30 degrees. And this is equal to 42.5 newtons, rounded up. Then the force of gravity is equal to 5 kilograms times by 9.81 meters a second squared times the sine of 30 degrees. And this is equal to about 24.5 newtons. Since we used the SI values here, our answer came out in newtons. Now, to find the frictional force, the formula is the coefficient of friction times the normal force. If we look at static friction, we can determine if the block will slide. If the force of gravity is greater than the force of static friction, then the block will slide. So, let's calculate the force of static friction. I'll put a little s to mark that static, which equals coefficient of static friction times normal force, which in this case is 0.4 times by 42.5 newtons. Which equals about 17 newtons. Now, this means that the force of gravity is greater than the force of friction, the static force of friction. Therefore, it will slide. The force of gravity is greater than the force of static friction because the force of gravity was 24.5 newtons, while the force of static friction was only 17 newtons. So 24.5 is greater than 17. Now let's calculate the acceleration. For this, we'll need to use the coefficient of kinetic friction because it involves the movement of the block. So the force of friction for the kinetic friction, I'll put a little k to mark it as kinetic, is the coefficient of kinetic friction times the normal force. I'll switch pen to make this a little more clear from the other side that we're doing. So if we plug in the values, this is 0.3 times it by the normal force, which is 42.5 newtons. Which gives us a value of about 12.7 newtons. Now to determine the acceleration, we can use Newton's second law, F equals ma. Meaning that force divided by the mass is equal to acceleration. Now, we need to determine the net force. The net force in this case is going to be the force of gravity minus the force of kinetic friction because it'll be moving. So, force is equal to Fg minus the force of kinetic friction. So that'll be equal to 24.5 newtons minus 12.7 newtons. Which equals 11.8 newtons. So the net force acting on the box is 11.8 newtons. Now finally, let's calculate the acceleration. We just need to plug in our values to the F equals ma equation. So we have acceleration is equal to 11.8 newtons divided by 5 kilograms. Since these are in SI units, our acceleration will be in SI units. Which will be meters per second squared. So our final answer, so the acceleration is about 2.4 meters a second squared.